Okay, here's our second example here. A farmer has 800 meters of fencing and wishes to enclose a rectangular field. One side of the field is against a country road, which is already fenced. What are the dimensions of the field with the largest area? So let's draw a little picture of what's going on here. We've got our country road coming along here like this. I'll even label it road. And we want to put a rectangular area with one length, one side of the rectangle against the road. So we've got three sides that are going to need fencing, and we'll just label these sides as the width and the length. And inside here, we're going to have our area. We don't know what our area is. So what do we want to optimize in this question? Yeah, we want to optimize area, so we're going to have length times width is going to be our formula here. We've got two variables here, so we want to write one of these variables in terms of the other one. And to do that, we're going to need to use this relationship up here about the amount of fencing that we're given. So if we have 800 meters of fencing here, we know that that 800 has got to be one of our widths plus our length plus the third side, which is another width. So 800 is going to equal 2W plus L. So we can use this to express either length in terms of width or width in terms of length. Now, is there a better option to choose here? Austin's nodding his head. What do you think? There is. If I solve for length, I end up with length equals 800 minus 2W. If I solve for width, I end up with 800 minus L divided by 2. Now, maybe it doesn't really matter, but I don't like working with fractions if I can avoid it. So I would probably choose this one over here. Okay. You can work with fractions if you like. I tend not to. So we've got the relationship between our two variables here. So we can rewrite our area expression here as 800 minus 2W all times W. And before we go any further, let's see, are there any restrictions that we can place on our variables here, length and width? There's one obvious one. The length and the width both have to be positive numbers, right? So these both have to be greater than 0 because they represent real dimensions. Is there a maximum value that your length and your width can have? Well, if I make my length 800, that leaves none of the fencing left for the width. So that would sort of be the absolute largest I could possibly make my length. I mean, I only have 800 meters of fencing, so I certainly can't have a length that's 900. In terms of my width, because I need two widths to make my fence here, each one of them has got to be less than 400. If I make my width 400, that uses up all of my fencing. So we do have restrictions here that are placed in our length and our width. But let's move on to trying to find our maximum area here. So we've got the function that we want to take the derivative of. I'll just expand it before we go any further here. So 800W minus 2W squared. And let's take our derivative to get 800 minus 4W. Let's set this equal to 0 and solve for W. That's going to give us 800 is 4W So W equals 200. Which is in our domain, so that's good. Let's make sure that this is actually giving us a maximum rather than a minimum. So let's take our second derivative, which is -4. So we don't even have to sub in W in this case. This is always less than 0. So we obviously have sorry, I drew this guy wrong. He is negative, so he's unhappy. So we definitely have a local maximum, okay, just like we were looking for. So we've got our width. Let's find our length. Our length is, go back to this original expression here, it's 800 minus 2 times W. So 800 minus 2 times 200. And our length is going to be 400 meters. So the largest area is when length is 400 meters and W is 200 meters. And we're done.